This is our lesson for Monday, March 22nd, e-learning, over section 7.2, solving exponential equations. This is day 2. On Friday, we learned the general formula of an exponential equation, and we solved application problems like numbers 1 and 2 in class. If you were absent, see 7.2 examples, day 2 in Canvas. Today, we're actually going to focus on the second formula for compound interest, which you can see right here. And that's where A equals P times the quantity 1 plus R over N, all raised to the NT. In that formula, A is the amount that you have in an account after T years, where P is the principal amount invested. That's how much money you have in the account. R is the annual interest rate, which is always expressed as a decimal in the formula. And N is the number of compounding periods per each year. So let's move down to the back of this page. If you were not in class, you can find this handout on Canvas, and we are going to focus on number 3. It says an investment account pays 4.2% annual interest compounded monthly. If $2,500 is invested in this account, what will be that balance after 15 years? So as we look at our problem, we have to understand the 4.2% annual interest is the rate, that's R. We want to use it as a decimal, so that would be 0.042. The interest is being compounded monthly. That would mean N is 12 because there are 12 months in each year. The amount we're investing in the account is $2,500. That's the principal that we're starting with. And we're doing it for 15 years, so that means T here is 15. You can see our formula on the left side, A equals P times the quantity 1 plus R over N raised to the NT. So in that formula, when we want to calculate the account balance, we're going to say A equals 2,500 times the quantity 1 plus R, which is the 0.042, divided by N, which is 12, the number of compoundings, raised to the N, which is 12, times T, which is 15. And a lot of calculators will handle this entire input. Sometimes, though, it's easier to do some of this by hand first. So, for instance, you might want to take the 0.042 and divide it by 12 and add the 1, which most calculators are going to do the division before the addition because it's in the hierarchy higher. That all becomes 1.035, and the 12 times 15 for the power is 180. And so now it makes it a little easier to input it into your calculator, and that's really up to you. The setup is absolutely required, that line. So then when we calculate this, we get $4,688, and we round to the nearest cent or hundredth, so that's 87 cents. Let's try our second one. It says find the account balance after 20 years if $100 is placed in an account that pays 1.2% interest compounded twice a month. So in our formula, that means for P, we want to input 100. Then we'd have 1 plus the rate, 1.2% as a decimal is 0.012, divided by N, the number of 2 times a month would mean N is 24. That's how many times in a year. And then it gets raised to the n, 24, times t, which is the time, or 20 years. And again, if you want to use an intermediate step to simplify what's in parentheses, as long as it's a terminating decimal and you don't lose accuracy, that's fine. We don't want to lose any accuracy. We want to leave our calculator to do the computation to the nearest decimal place. And so in this case, we're going to get $127.12. Our final problem. An investment account pays 5.4% in annual interest compounded quarterly. If $4,000 is placed in this account, find the balance after 8 years. So A is going to equal the 4,000, that's the principal, the amount you're investing, times the quantity 1 plus the rate, which would be 0.054 for 5.4%, divided by n. Compounded quarterly means 4 times per year, and then raised to the n for t, which is the time, and that would be 8. And here that's going to be 4,000 times the quantity 1.0135 raised to the 32. And again, I didn't have to round, but if I did, I might let my calculator handle the entire computation. Here I get $6,143.56. So you need to know the formula, which is A equals P times the quantity 1 plus R divided by N, all raised to the NT. In that formula, again, P is the principal, the amount you invest. R is the annual interest rate expressed as a decimal. N is the number of times you're compounding. And T is the number of years you're compounding the interest. You plug in, you let your calculator do its work, and you get your answer, which is the amount in your account with the interest included. A couple of things to mention is compounding periods. Of course, quarterly means 4 times a year. Monthly would be 12 times a year. Annually would be once a year. Sometimes they will say something like bi-weekly. Bi-weekly typically means every other week. And in a calendar year of 52 weeks, that would mean 26 times. A lot of times people are paid bi-weekly. Sometimes that can mean twice a week. If you look it up in the dictionary, you'll see both interpretations. And depending on what you're doing, you might find a slightly different answer. So if that's the case, we'll discuss that in class. But it should be fairly straightforward. As far as your homework, this is listed below. It's also on Canvas, page 464 to 467. You're doing numbers 6, 15, 17, 19, 20 to 23 all, 30, 43, 54, and 56. It will include the compound interest type problems, as well as those from the front side that we covered in class on Friday, and again can be found on Canvas as you look at 7.2 examples for day 2. Please don't forget to upload your assignment from the equations where you equate the bases. That slot will be there for you to upload that, and we will go over any questions in class on Tuesday or Wednesday. Have a great day. Thanks.